Welcome to the E-PG Padashala, the PG program, the lecture series in PG program for computer science, and this is the 26th module for the course compiler design, where we will be talking about backpatching and procedures, where we will be generating 3 address code for backpatching and procedures basically. Till now we have basically looked at the 3 address code for control flow statements and Boolean expressions, which also incorporates the short circuit information. Now this is a different approach to generating 3 address code for the control flow statements along with the Boolean expressions, where the procedure is called as backpatching. So we will see what is backpatching and why should it be done, along with how it is being done in this module. That is the primary objective. On top of it, the Boolean expressions will also be combined with the control flow statements to generate intermediate code incorporating backpatching. In addition, SDDs for procedures will also be discussed in this particular module. So control flow statements, Boolean expressions in the context of backpatching along with the SDDs for procedures. So backpatching, why do we need it? What is the motivation behind doing this backpatching is, the syntax directed definition is typically done in 2 passes. The first one is to construct the syntax tree. The second one is a walk is performed on the DFS, on the work is performed using a depth first search on the SDD to perform your syntax directed translation. Now in a single pass, labels may not be known, and hence we introduce a technique called as backpatching. So why do we need labels? So far we have looked at in the previous modules that we have to create a new label, etc. And this new label will be the truth label or the false label. Sometimes exact position of truth label you may not know in advance, depending upon how many statements are there in the S1 and how many statements are there in another. If the body of the statement is going to be again containing an if and an else, etc. So how do I evaluate that? So in order to do that, you may not know the labels and the exact point of jump in one pass. So therefore we have a technique called as backpatching that is going to help us do it. This backpatching, it typically generates a series of branching statements with the target of jumps unspecified. So at the first instinct, what happens is you will simply generate code with a blank, meaning that I do not know where to jump. Okay, that is your situation. Then there is one more pass is carried on, and in the second pass we fill all the labels. Okay, we fill all the labels with corresponding true and false labels, and then that completes your 3 address code for a particular control flow statement that incorporates Boolean expressions. So here in order to support that, in order to support which are false and which are true, etc. If you in the previous modules we have said there could be multiple true points. If you incorporate short circuit information E1 or E2 and E3, okay, so E1's true can be the complete expressions true. If E1's false can be the complete I have to evaluate then E2 and so on and so forth. So therefore there are multiple positions where my true information or the false label need to be filled in. So to do that, we are going to use here the function, 3 functions. One is the make list function, the second function is the merge function, and the third function is the backpatch. Now make list of I, okay, that is going to create a new list containing the 3 address location I, and it returns a pointer to the list. This is simply a linked list of 3 addresses, where the address will typically be corresponding to a line number or corresponding to a quadruple information of your 3 address code, okay, which is nothing but the 3 address location. So we say 100 is a line number of a quadruple, 101 line number of a quadruple. So that is going to be the make list will create a linked list of such information. Then merge P1 comma P2 will be given 2 lists whose pointers are P1 comma P2. This is going to merge them and it returns a pointer to the concatenated list. That is, it is going to join 2 lists together. Okay. So then the third one is backpatch P comma I. P is a pointer to a list and I is the target label. So how many ever elements this list contains, which is pointed by P, in all these elements you backpatch it with the line number corresponding to I. That is what this basically says, that is insert I as a target label for each of the statements contained in P. So, P is a pointer to a list. This list will have so many items. Each item will basically have a line number, that is which area needs to be backpatched. Now, what does the backpatch function do is, it goes through it traverses the list, gets each item from the list and then tries to fill up that with the line number I. Okay. So, which means that this is the label corresponding to this particular line number, which is available as a list in pointed by P, okay, which is available as a list pointed by P. Now, let us say this is going to be the example. We will look at how this basically looks and then we will come back with how to do this based on the syntax directed definition. Supposing say I have this A less than B or C less than D and E less than F, we know the code corresponding to this. Now, I am not going to generate labels here, I am going to simply say a dash, meaning that I do not know. Okay. Now, what do we know? If A less than B is true, then the complete expression is true. Okay. So, I simply say here go to universal true or go to the expressions true. But if A less than B is false, so here what do we say is I have to go to line number 102, that is what we already said. So, this 102 will be fixed, will be filled only in the subsequent pass where the false list of the complete of this expression, the false is of the complete of this expression is going to line number 102. Now, similarly, if C less than D is true, I have to evaluate E less than F. So, I will say here go to 104. If this itself is false, we know the ANDing of these two is also going to be false. So, therefore, that will evaluate to the expressions false. So, we will say here go to false. So, is the case for the next one. If this is true, I would have come to this line number only if A less than B is false, C less than D is true. Therefore, if E less than F is true, that will go to the universal true, and if this is also false, I will say it is going to be the complete false of the statement. So, this is done. So, this is done in the first pass. In the second pass using the backpatch technique, we will fill up the labels corresponding to the blanks which we have left in the first pass. So, this is what we are going to do. We are going to here insert one more variable, one more non-terminal here to the production of the expressions involving E and E. So, here E produces E1 or ME2. Okay. So, this M is basically the new non-terminal, and this M says find the next quadruple, that is to increment the line number, go to the next quadruple, create the next quadruple or fetch the next quadruple. That is what this M basically tells you. So, if I am in line number 103, if I have an M here, M will say go to next quad. So, I will say M will get me a line number as 104. Okay. Now, what I am going to do here is, this is similar to the previous one only, but I am going to here create a list. So, what do we already know? If E1 is true, okay, then the expression itself is true. Okay. If E1 is false, then I have to evaluate E2. Okay. So, what will I do here is, I will create a function called as merge, which is going to merge the true list of E1 and the true list of E2. That is, here it is no longer true and false. It is true list. That is, again expression E1 could comprise of a sequence of expressions. So, therefore, I will call this as E1.TrueList and E2.TrueList. That will be corresponding to E.TrueList, and E.FalseList will be equal to E2.FalseList. Okay. And I will finally backpatch E1.FalseList with M.Quad. That is, what do we know? If E1 is false, then I have to evaluate E2, right. So, this E2 will be available at the next line number of E1. E2 will be available at the next line number of E1. So, that is fetched using this M.Quad information. So, finally, I will backpatch E1.FalseList with M.Quad. So, this there will be a simple go to dash, right. So, that dash will be pointing to M.Quad. M.Quad will be the next line number after completing expression E1. So, supposing I have only for simplicity, if you assume only one statement comprising in E1, then E2 will begin in the next line number. So, that is backpatched, that is given by this M. So that is assigned as the information corresponding to false list of E1. Okay. Here again the same thing is carried out, where the false list of the expression E is the merged false list of E1 and E2, and if E is the true list of E depends upon the true list of E2. Okay. Now backpatch E1 dot true list with M dot quad, meaning that if E1 is true, what will I have to do? I have to evaluate E2, right. So where will E2 be available? After the code corresponding to E1. Again for simplicity, if you have the code corresponding to E1 as if A less than B, go to dash, then I have a go to dash. So I have two line numbers there. The third line number is fetched from M. Or even if it is a complex expression, after completing E1, M will point to the next line number, which is the first line number corresponding to E2. So that is fetched from M dot quad, which is backpatched with E1 dot true list. That is the statement where E1 dot true is going to begin. E1 dot true should be filled up. In that, what I do is I will basically put this. So what did we say about the backpatch function? It is going to take a pointer to a list. Now this is a list. This list will contain so many elements. In one of those elements will typically be the true value of E1, that is the true line number corresponding to E1. So in that you will fill up M dot quad. So the other two are exactly similar. E produces not E1 and E produces E1, where here the true list and false list are reversed. Here the true list and false list are same. So rather than creating as a simple label, you are creating as a list of labels, and you will know the pointer corresponding to the head of the list. Going ahead with this, again here E dot true list will be make list of next quad, E dot false list will be make list of next quad plus 1. So here I am creating when I encounter an expression, I am creating two pointers and I am making a list. Okay. That make list corresponds to next quad and next quad plus 1 here. So next quad here will be the current line number, okay, and next quad plus 1 will be the next line number. So true list means, supposing I am generating a code for a particular line number, that will be incorporating the true information. Okay. So we already know at line number 100, we will say if A less than B, go to something. So 100 corresponds to the position at which I have to come back and put the true label, okay, where I have to go. So my true list will have 100 as one of its argument. That is fetched using the function next quad. We have already seen next quad in the modules 24, where we said it is next state. Okay, next state is the next line number basically. So we are looking at next quad as the returning the current line number here. So here next quad will return that, which is the line number corresponding to 100, and that will be put into E dot true list. And what will be false? Normally we say if A less than B, go to true, go to false, right. So that go to false will be the next line number following the current line number. So therefore false list will be make list of next quad plus 1. And after that you emit the 3 address code. If id1 dot place, relop dot operator, id2 dot place, go to dash, go to dash. So this is what will be emitted. Now this will be, this first line will be the E dot true list line number, which is nothing but 100, for example say, and this will be 101. So that will be corresponding to E dot false list line number. And after this, when you have a true and a false value here, E produces true will be E dot true list will be make list of next quad, and E dot false list will be nil in this case, and you will simply do an emit go to dash. Similarly here, if it is false, you will simply say false list will be only that particular line number, true list will be nil in that case, and you will say simply a go to dash. So this is what we have here, and on top of it you can also have expressions, the control flow statements also as part of your backpatching example. So typically we know that expressions are part of your control statements, control flow statements. So therefore you will have this also as part of your backpatching has to be done also for this control flow statements. So here this is the grammar which you are going to use. So, these we already know, while expression do statement. You will also have a begin L and end, or a simple A, or where this L can be L semicolon S or S, because it is going to be the Pascal syntax here. So, where I am going to have here two attributes, one is called as S dot next list and L dot next list. So, where we had the true list and false list as two attributes, now we are going to have also S dot next list and L dot next list, which is the backpatch list for jumps to the next statement after S. Okay. So, where will I jump? So, for example, if then else, okay, if there is a if then else grammar, the S, this S is next and this S is next should be combined as S dot next list statements. Okay. So, that is why we have this function. It could be a single component also, but it could also be a list of statements which is going to be part of the next list function. Now, let us look at this. So, S produces A, this is a very simple statement for which you do not have a next list at all, it is a simple statement. So, I will say here S dot next list is equal to nil, and for the statement S produces begin L end. So, the next list of L is nothing but the next list of S also. So, S dot next list will be equal to L dot next list. Now, if it is F expression, then M S1, again M is used to get the next quad information, next line number information. So, what will I do? Again, this is similar to the previous one. You backpatch E's true list with M dot quad, and you say S dot next list will be merging of this false list along with this S1's next list. Now, this is what we told in a different way there. We said S dot next is equal to S1 dot next, and we also said E dot false is also equal to S dot next, and so on and so forth. Now, we are representing that as a combination of the next of S1, the false of E. If you merge that, that correspond to the next of S. Okay, all refers to the same position, same line number, whatever you want to call. And then here L produces L1 semicolon M, yes, again M is to get the next line number. So, you will say L1's next list will be whatever M is pointing to, and L's next list will be S's next list. So, L dot next list is equal to S dot next list, and the next one is L produces S, just the reverse of this. Okay. And M again is the same as the previous one. Now, let us look at the if then else and while M. So, in if then else we have actually inserted two M2s, M1 and M2 here. This M1 correspond to fetching a line, creating a quadruple for S1, and this M2 corresponds to creating a quadruple for S2. Now, N corresponds to creating that is branching, that is creating a go to, that is you have to skip this S2 if I see a else part. After evaluating this if, I should skip this part, right. So, for that you are creating here a N, just to create one line number and then trying to issue a go to statements there. That is why this N is basically done. So, if you look at the production correspond to N, N produces epsilon, N dot next list is equal to make list of next quad. So, you simply create a next line number and you emit a go to. Okay. So, this go to will be what? This go to will be S is next. Okay. That is done by here. Okay. This go to is done by S dot, this go to should be filled with S dot next, which is done here. Okay. So, backpatch E dot true list with M1 dot quad and backpatch E dot false list with M2 dot quad. So, these two are very simple. Okay. Just getting this line number M1 and M2 accordingly. And then next list of S1, S will be S1's next list, and it should have three components actually, S1's next, N's next and S2's next. So, how am I going to combine that? I am going to use a merge of merge, that is merge will take two arguments. The first argument will be S1, the second argument will be another merge function which is going to merge N dot next and S2 dot next. This will return a pointer and that will be merged with S1 dot next. So, that is going to be S dot next. So, this N here is to issue a simple go to here to skip the body of the else block if this condition is true. Okay. So, that is what we have here. And the last one is while M expression do S1, again this M1 is to create a line number for expression. This M2 is to create a line number for S1, which is similar to the previous one only. So, backpatch S1 dot next list with M1 dot quad, okay, and backpatch E dot true list with M2 dot quad, which is the same. S dot next list is equal to E dot false list, we already know that, and you have to emit a go to. This go to will be to begin, okay. So, that is dash here, which is a emit, simply a go to. That go to will be going to S dot begin. Okay. Now, that will be again nothing but S1's next actually. Okay. So, with this we already know this syntax, and this is the basis for creating that. Now, where you had simply a go to here and a next, you are going to have now a next list and a list of statements. Again, while you have to go to begin, the same thing should be incorporated, but the incorporation should be happening as in two parts, because you are not aware of the labels already. So, consider this A less than B or C less than D and E less than F. So, this is a simple expression. So, I said ID1 relop ID2 go to dash, then you have to emit go to dash. So, this is what is corresponding to A less than B, and then again C less than D, and again then E less than F. Okay. Now, I am going to look at this. This is the grammar corresponding to expression. So, E produces E or ME, and this E produces E and ME. Now, I am evaluating this. Now, I have a single expression, the true list is this and the false list is this. Okay. So, the next one is again the true list is this and the false list is this. Again here the true list is 104 and 105. So, this depends upon whatever we have just now created. So, the true of this expression is 100, false list is 101, the true of this is 102, false is 103, true of this is 104, false is 105. Okay. Now, after that, when I have a combination here, what will I do? I will say that E dot true will be the E2 dot true list, okay, because it is an AND. So, E2 dot true will be available here, and E dot false will be the union of these two false, which is 103 comma 105. Now, what about this here? E dot true will be E1 dot true comma E2 dot true, and E dot false will be E dot false only. E dot false will be E2 dot false only. So, the true, this is an OR operator, therefore, the true of this will be the union of true, and the false will be the false of the false of E2 typically. Okay. So, this is what will basically be determined. After that, what it basically says is E dot true will be, the entire expression's true will be 100 comma 104, and the entire expression's false will be 103 comma 105. So, at 100 comma 104 you should say true and true, the expression's true. At 103 and 105 I should say false and false, which is the same result which we got earlier. So, this is overall true. Now, here I say go to 102. So, why did I have to say go to 102 here? We know that if this is false, okay, we say E dot false is equal to backpatch this with M dot quad, right. So, 101 should be backpatched with M dot quad. Similarly, here the true of this 102 should be backpatched with M dot quad here, which is nothing but 104. So, 102 should be backpatched with 104, and 101 should be backpatched with 102. So, that is what is available here. So, if A less than B, go to overall true, and 101 is go to 102, and here again go to 104, this is overall false, and this is overall true again, and this is overall false. So, this overall true and overall false can be looked at from the derivation tree which we have already constructed here. So, that is going to be the overall true and overall false. So, 100 and 104 are overall true, 103 and 105 are overall false. So, that is what here we have. So, this is just considering the expression alone, the Boolean expression alone. Now, looking at this in the context of the grammar which we already got, this is what we have already done in the previous module. Now, the 3 address code, how does it look like? If A less than B, go to dash. So, this is what we have here, which is exactly similar to the previous one. Okay. So, here this is the truth of the while loop, okay, and this is the false of the while loop. So, that should be going to the next of yes, okay. So, if you look at that, applying all the logic which we have already talked about, this is what it is going to be, and then if C is less than D, I have to go to 104, that is evaluating the body. So, which is body here, and then there will be a go to, okay. Go to will be going back to 100 here because it is a begin, okay. And then I will look at x is equal to y minus z, and then go to 100. So, that is what we have basically looked at. So, 107 will be go to 100. 108 will be whatever is the false of this while expression, okay. So, with that in mind, we have looked at backpatching. So, backpatching is putting the information, putting the line numbers and the labels corresponding to true and false values in two passes basically. And the next thing is translating procedure calls. So, this is a typical procedure call in Pascal where I have a call ID and a E-list, and E-list produces E-list comma E or E. So, if I have a function call something like this foo a plus 1 comma b comma c, then this is how it is evaluated: parameter t1, param b and param t, and then call foo with 3. This is what you basically foo with 3 arguments, that is what we basically look at here. Now, here this is the corresponding SDD for this one, that is for this E list the items are put into a queue. So, for each item P on Q, emit param P and then emit call I dot place in the queue, okay. So, you emit param P means you said param A, param B, whatever it is, whatever is the available list in available parameters in the list E list, okay. And then you append E dot place to the end of Q, so that is what this basically does. And after that you initialize Q to contain only E dot place, okay. So, that is what we have done here if you could recollect. So, param T, emit param T1, emit param B and emit param T2, where T1 is A plus 1, T2 is 7, and so these three will be put in a queue, and then that will be called one after the other, okay. So, that is what is this 3 address code trying to do it, and it will be evaluated on a one-to-one basis. Now, after that we are done with the backpatching and the procedure calls. Now, to summarize this module, so here we have looked at Boolean expressions with backpatching. We have also looked at the control flow statements in the context of backpatching, where it incorporated if then else and do while, and you are incorporating this by creating new attributes for the non-terminals S and L, where you will have a next list and a next list, L dot next list and an S dot next list in addition, against your S dot next, which is a single label, and a L dot next, which is also a single label there. We are going to have now a list of labels which you have to go next and following that. And then we also had here a true list and a false list, where the true list will be having a set of items in a linked list, where each item corresponds to a line number that has to be backpatched with a true value, and false list again will be again a list singly linked list of line numbers from quadruples, which has to be backpatched with a corresponding false value basically. So, and then we have also looked at 3 address code for procedures. Now, with this we are left with generating 3 address code for switch case statements and dealing with multiple variables involving mixed operators like Boolean and expression, arithmetic expression, etc. So, that will be discussed in the next module. Thank you.